Senior, you don't want to improve your lighting?
Where's the light? Let's.
That's the light.
From the light.
Lighting is good though, I think, on my phone.
You could take out the flashlight from your phone and just like angle it right.
That's gonna look very weird.
Very, very bright.
Yeah.
That's fine. All right, let's go.
Okay, I am recording, by the way.
Okay, so hi, I'm Istvan. I'm a senior software engineer here at the University of Miami, and today I'm going to talk about a project that we worked for our class, EC 417.
Okay. What did you guys do for the project?
So for this project, we used an FPGA to actually create a maze game. So we used the G sensor and the LEDs of the FPGA to provide input for the game, and the player could actually move around in the game using the board.
Cool. And so how does the information transfer from the G sensor to the board, or like how does it work? Like,
so the way it works is we have two separate sides of the game. We have the visual aspect of it, where the text gets displayed, and then we have the synchronization between the game and the board. We use a custom library that we built to display graphics using end curses, so it's a little bit easier to code in. And for the board, we use the given libraries that were given to us in one of the labs to actually interface between the FPGA and the actual Linux operating system that's running on this chip.
what components of the board are you guys using?
So we ended up using the G sensor. We're using the LEDs. So the G sensor is used for movement. So if you move the board around, the LEDs are used to show if you won the game. And we're running Ubuntu right now on the board. So those are the components that we're using.
Okay. Maybe you guys can show us a demo. Okay, demo. Okay.
So my name is Martin. I'm gonna show the demo. So first we're gonna run the program right here with ./a.out. As you can see, you have three options. You can either quit the game, you can get the info about the game, how does it work, if it moves right, left, up or down.
Okay.
And also, we're gonna try to play and to win to the enemy. So we are the green square, and the enemy is the red square. They're trying to catch us as fast as possible. Our goal is to get to this purple square before the enemy catches. So we implemented the enemy's like an algorithm to try to catch us. However, at this time we kind of know how to beat the enemy, but we're gonna try to beat it again.
Looks like it's hard to explain while you're playing.
So what algorithm did you use to?
We use the greedy algorithm to get to the enemy to try to catch us. As you can see, they're following us to get to the goal. And once we get to goal, we're gonna see that we're gonna have a trace of our path from the beginning of the game till the end, and the lights from the board are gonna turn on to show that we won the game. And then we can quit it and play it again, or either quit the game.
Okay. What would you guys have done differently? If you guys wanted to do it again, how would you improve it?
So the way we kind of made the game is we made it so each maze is uploaded through a text file, so we can easily change these text files in order to kind of create different levels within the game and make it a little harder as you go on throughout the levels. We also could have implemented the LEDs and made kind of lives. So like if you got caught by the enemy, then you would lose a life, lose an LED, and that would kind of keep going. One more thing that we could have done is we could have had
The buttons.
oh yeah, the buttons. We could use the buttons on the FPGA in order to navigate the game and click play, info, or quit.
Anything to do like to? I noticed the speed was a little slow. Maybe.
So
You can-
yeah, we tried to increase the speed, but we noticed that it kind of lost sync with the updating on the screen and the actual reading of the G sensor. So when we increased the speed, we actually lost control of the player.
Okay. Sounds cool. All right. Thank you guys.
Thank
Sure.
you.
Thanks.
Thank you.